who here? This is a talk about scalable workers. It's going to be talking specifically about PHP, but the theory can apply to everything. It's a lot of the languages. So who here would identify themselves as a PHP programmer, or PHP's at least in their tool belt, in their toolkit? All right. How many of you guys are using some type of PHP worker processes at your current job? Okay, we got a few. Awesome. Good. All right. Okay, quickly about me. I'm a director of development for Desert Digital Media. We do like KSL.com, desertnews.com, OK.com. There's a couple of properties we do. I can't remember, like Utah.com. So some brand name websites from around here. I'm trying to look up the numbers, how many millions of pages we serve a month, but it's hundreds of millions, I think, as a company. So we do a lot with scaling. I'm also the current president of the Utah PHP user group. In fact, there's a handful of people I recognize, but a lot of people I don't. We have meetings every third Thursday down in Bluffdale. If you go to uphpu.org, that was probably the best thing for my career, is starting going to these meetings, because I learned so much. I got to meet so many people, and really, that was kind of one of the things that really helped teach me everything that I know. I've been a PHP developer for about 8 years, and I'm also a goofy dad. So if you want, there's a Vagrant, there's a Git repository with some of this code we'll be showing. If you want, you can follow along. If you don't want to type that out, you can try and type the bit.ly version, but it's not required. Normally I like to have really nice slides. I'll spend lots of time, get awesome pictures and stuff. But then I had this guy come along, and so I no longer have time to put together awesome slides. So sorry, there's no fancy slides. All right. So we're going to talk about the problem. And I think everyone here at some point in time has had a blog or worked on a blog, or it's a pretty common thing to use a blog. And so, when you first write your blog, you might say, "Hey, I want to fill out the form for the whatever information I want for my blog post." And then when I hit save, so go ahead and save it to the database, and then we display, "Hey, your blog post was successful." Go ahead. It's pretty typical. But as your blog might grow, you might add some plugins, or you might do just engineering, write some more code to start doing more and more things after you've saved your blog post. You might say, "Oh, I want to post to Twitter and Facebook. I want to send some emails. My blog's very popular, so I want to warm the cache on the front end, so when people hit there, there's no delay. I might have to, I can't remember what I did this for, update some queues. I have some widgets that I have that say, hey, I want to update this blog post to show up here. I might have some images that I've uploaded that I want to go ahead and create, resize, get the perfect web format, stick them up. I might want to go through and find some related posts, build some type of index like that so I can display on the page. And I might want to do another thing, and another thing, another thing, another thing, another thing. Tons of things. And so the problem is the point between here and here over time is you will get a ton of stuff that you want to do in between different actions. And the problem is if you do kind of this linear method where I fill out the form, save the database, post to Twitter, I can't remember all the other things I listed, is basically it's going to be slow. It's going to take a very long time, or it might even be that slow, but it's not an awesome, responsive experience. Maybe if it's your own blog, you don't care, but if you're running a website like WordPress.com and you're hosting blogs for other people, then you want your users not to have to wait 3 seconds to post to Facebook, Twitter, and so there's a lot of problems with the approach. It's longer, it takes longer to get from save to success. And then what happens if there's a problem? What happens if Twitter? This never happens, but what happens if Twitter goes down? And that's your second step. And you're waiting for 30 seconds. And then what about all the things in that stack? Do the emails not get sent out? Do my images don't get created? Does my cache not get warmed? And so as your application will grow, there will naturally be this idea of saying, okay, I want to have some type of way to do work in my application that's not tied to a page that I just rendered in my application. And so the solution are PHP workers. And it's really simple. They're not that complicated. There's some caveats to running them, but once you're able to set up the system, you're going to be able to control the scalability of your application in a much more controllable way. All right, so what are our workers? They are a separate PHP process that typically run from the command line prompt, or the CLI, command line interface. So like if you open up your terminal, you type PHP, then some type of script name, you hit enter. That's basically it. And these, unlike a website, if I go to justincarmony.com, hit that page, it's going to open up PHP, execute my code, and then quit all within less than a second. These are going to be long-running processes that they're going to sit there and they're going to wait and they're going to listen to a queue for jobs. They're going to listen to some location saying, hey, I'm just going to wait until a job comes in, then I'm going to process that job, do whatever is required for the job, output it out, and then wait again for the next job. When it receives a job, it does it, and then when it's finished, it listens for more jobs. And so this is kind of what the workflow is going to look like. We have a web application, and we say, hey, our web application wants to output a job. And so we're going to take that job, and we're going to stick it in a queue of jobs. So we have our queue of jobs, and it lists them all out. And so our application will go ahead and stick that job at the end of the queue. Now here's our PHP worker that's running in the command line, somewhere, it's managed some way. And it's going to listen to this queue of jobs. And it says, hey, there's a job available for me. So I'm going to go ahead, pull it down. I like little animations. It took me forever. Just kidding. Actually, I'm not. Take it, suck it in. I'm going to go through, do my processing, whatever it is, whether it's talking to Facebook, talking to Twitter, generating images, sending emails, whatever it might be. And then I'm going to output my result. And whether that's a reporting, say, hey, I finished this job, whatever, good. And then then the process continues. And you just take jobs, came in, and they spit out results, and I didn't want to go through the animation process for all those things. But that's basically the workflow. It's not that complicated. So we ever fill out our form, and I missed a step. So we'll ever fill out form, we'll save the stuff to the database because that's something like you can't. You got something that's a very high priority. You want to make sure it gets saved to the database. So that step would be right here, if I remembered it at 2 o'clock last night in the morning. And then I'm gonna go ahead and queue my jobs. And so I'll go ahead and say, hey, queue up all these jobs in a separate queue, and queuing these jobs is very, very fast. And then go ahead and display my success page. And then in the background, unbeknownst to the user, whether there's 1 or 100 things, it'll go, my workers will get those jobs, process them, and send them on their way. And so, in theory, it's like super simple. Like it's not rocket science. It's pretty straightforward, but let's see how you actually do it. That's my son trying to use a computer, which is kind of fun to watch. He just mostly drills on it. Okay, so here's what we're going to need. We're going to be using PHP 5.3, and for our queue, we're going to use an application called Beanstalk. I used to use Redis in this position, but Beanstalk adds just a handful of features on top of it, while still staying very, very high performant. That it's now my go-to application for managing like a working queue. And so for our PHP library to talk to Beanstalk, we're going to use a library called Beanstalk. I think that's how you pronounce it. And then to make sure that we have workers running and they're listening for jobs, we have kind of 2 options. We use the poor man's management. It's a tool called Solo, which just uses a cron job and says, hey, make sure this process is running. And if it's not, every minute when the cron executes, it will do it. Or you can be a little more sophisticated, use a tool called Supervisor. And both of them are pretty easy. We want our workers to be able to report their status. So I'm going to use Redis for that. It's high performance. If you're not familiar with it, it's just a key value database, key value store that's in memory, so it's extremely fast. I have another presentation where we can, you can show a demo. It can do like 300,000 operations per second on commodity hard, like on my laptop. So it's super, super fast, all in memory. And then to talk with Redis, we use a library called Predis. Yes?
I was talking about something Redis, another thing is it's atomic.
Yes. Yeah. Yes. Yeah. So if you can hear, it's atomic, meaning operations happen in parallel and all. So you don't have to worry about operations stepping over each other. And FYI, I'll put these online. So if you go like to the joined in page and the lanyard page, there'll be links to these slides. So you don't have to furiously take notes. I probably should have said that at the beginning. But so you don't need to fill out, you don't have to copy the slides. I'll have them online. And you can ignore where I forgot to put the text in. All right. So when I actually submitted the talk for this, it actually had a thing saying, we were talking about Gearman. And honestly, Gearman's awesome to use. It requires you to compile PHP modules. So it requires a little bit more work. But if you know how to use the Beanstalk and Redis setup, whatever, if you understand the workflow, using Gearman will be really, really simple. And there's lots and lots and lots of talks about Gearman and a lot of information on how to use it. So I figured I'd rather give more exposure to Beanstalk, where it's easy to get information about Gearman. Any questions so far? If you have any questions, feel free to interrupt me.
Yeah, are these jobs like disk, saved on disk or just in memory?
Yeah, so Beanstalk has the option to do either or. So Beanstalk can be just in memory. So that way, if you want to throw thousands of jobs a second at it, it can handle it. And so typically what I recommend is you run 2 Beanstalk instances. You run one that will keep a bin log on the disk, so that way it can survive a reboot or a crash. And then so for the jobs that you absolutely cannot lose, send it to a Beanstalk queue that's being stored on disk. And then for the other jobs that like warming caches or pre-generating images and things like that, you could say it, you can send it to a queue that, hey, if I happen to lose a job or two, if there's a restart, it's not the end of the world.
So you can do a mixed environment.
You can do a mixed environment. Now you have to do it by running 2 Beanstalk instances, because you configure it on startups to use disk or not.
Okay.
And so, and basically all that will do is limit your throughput into Beanstalk. Yes.
And on the Redis end, Redis is actually disk-backed, so it automatically will go through and back up everything that's in your Redis database.
Yeah, you can do.
It can also survive.
Yep. You can do snapshots, or you can even do append to file, depending on the durability you need for Redis. And if you want to learn more about Redis, if you look on my blog, I have a presentation about it. No, the slides are there. Any other questions?
So, not all your workers have the same priority. Is there a way to assign a priority or a series of places that are stacked?
Yeah. So we'll talk about that. But basically, when you insert a job, you can put it. I call them queues. Beanstalk calls them tubes, but it's tube and queue for them is kind of a synonym. Like they mean a queue, and so you can put a job in and you can give it a priority, saying this has a 1 priority. This is super urgent. It has to go through. This is a 10. Or whatever. So you can put different priorities on, and you can have multiple tubes, where you say I can have a few workers that they only listen to these high priority tubes. So let's say when I send a welcome to, for example, perfect example is you wouldn't want to have the same queue for sending out your morning newsletter that you do for sending out your welcome registration email that has the verification link. Like if I did it at the wrong time and I had to wait an hour for your entire newsletters to go out to get my verification, that's going to stink, or I forgot my password. And so you can have workers that listen, 2 or 3 that are priority workers that only listen to tubes that you use for high priority, and then the bulk of your workers can listen to other queues that are meant for lower priority. And you can do that at your discretion. And you don't have to configure which tubes are what. It just, Beanstalk just kind of, it uses lazy, I think they call it lazy tubes, where if you pass to say, hey, put it in this tube, and it doesn't exist, it'll create it for you, and then after it empties, it'll get rid of it. So you don't have to worry about managing configurations of tubes. Your application will just kind of put the jobs in, saying it goes in this tube or this priority, and that. Any other questions? Okay. All right, Beanstalk's really simple to get running up on if you're running on any type of Unix, BSD type system. There's an apt-get, there's a yum, and the Mac has homebrew. There's also Mac ports for it, I believe, as well. If you're on Windows, use a VM. Check out Vagrant if you're on Windows. I'm serious, and it'll make your life so much easier. So Beanstalk will use this for PHP. It's probably the most well-tested and solid library out there. There's a bunch out there, but this should meet your needs unless there's some really unique case where there's a new library out that you want to use instead. It's installable via Composer, or you can just download it. If you don't know what Composer is, you can go to Russell Alstrom's talk tomorrow at 3. But it's like a dependency management system for PHP. And it's located at this GitHub repository. Okay, so the trick with making workers, this type of asynchronous worker environment work, is not about putting stuff in the queue. That's easy. It's really easy to say, hey, take this job, put it in a queue. That's very, very easy. The hard part is making sure your workers are up and running, consistently pulling in jobs, and sending them out and then reporting if there's any problems. Because what you don't want to have happen is have all your workers die and not restart. Like if you reboot your server and then all of a sudden you have this queue and like no emails are going out, no images are being generated, So that's the tricky part, is making sure your workers are up and consistently running. And so we'll talk about PHP workers. The awesome thing about this is if there's a library written in Python that's going to do the job that you need excellently, go use Python. Python can talk to Beanstalk. It's language agnostic. You'll just use its protocol, and you could write workers in Python. You could write them in Perl. You can use, you could use Tickle if you wanted. But we'll talk specifically about writing PHP workers because typically most of the workers I write are in PHP. So when you write your worker, there's a handful of features you're going to want to build or plan for. You're going to want your workers to be able to run for a long time. Hours. You want your workers to be able to self-restarting. And you want to be able to manually restart them yourselves if you want. You want them to be able to report their current status saying, hey, I'm idle, or I'm running, or processing this job, or I had fatal errors and I'm stuck. You want to be able to report. You want to use, you want them to be able to block, not pull. So what I mean by that is when they make a request out to Beanstalk, I want to say, hey, get me a job, and if there's no job, I'm going to wait. That way the instant a job comes in, I can grab it and put it through. A lot of people, before they do workers, they'll do something like a cron job. They'll have a database to say, hey, insert some jobs here, and then they'll have a cron that runs every minute, and says, hey, I want to, grab all this whatever work and process through it. The problem is that doesn't scale very well. Then what happens if you're like, I need to do it across multiple servers, have multiple crons right at the same time, make sure they're not stepping on each other's toes. And so that's where the worker route works a lot better. So that's why we like the blocking and not continually pulling every second, checking for a job. And you want them to be able to monitor their own performance. So that way you can kind of get a feel for, hey, do I need to have more workers? I need to spin up some more servers. And whatnot. So in PHP, typically the very first thing when your worker gets executed, you're going to run this function set timeout limit to 0. And that means, hey, let me run indefinitely. On your web application, you'd never do this because you don't want a bug and all of a sudden, all of your Apache, processes are running these really long running PHP requests and they'll keep running forever. So that's something typically you don't do on the application side, but from the worker side, on the command line, that's fine. You say, hey, just let me run indefinitely. And then I like to set a max runtime and then have them gracefully restart themselves. So what that means is PHP 5.3 has gotten a lot better about this with their garbage collection, but traditionally, PHP processes weren't engineered to run for very long periods of time. So they were typically engineered to run for milliseconds, and then they would assume they'd close and then be restarted like when you're using Apache. And so, if you have a process that's going to run 10 days, it might grow in memory and might have some, just some bugs or whatever. It might have some connections timeout. And so typically I like to say, hey, when you start, you're going to set a time limit of like an hour, and then you can add some additional time, random, 10 to anywhere from 0 to 10 minutes. That way all your workers don't restart at the same time. And say, hey, it'll run, and then I've run for about an hour. That's long enough. I'm going to exit, and then I'll let solo or supervisor start up a new instance of myself. It's just one of those. I've just ran into problems where if they've been running for like days and days and days, you can get some really weird bugs. And so, okay. So we're going to talk about the anatomy of a Beanstalk job. So what makes up a job is basically you have a priority. Well, I forgot one. So you have a tube you assign it to, and you have a priority. You can give it a delay. This is awesome if you have things like slave database replication. So you can say, hey, I want to put this job in, but wait 5 seconds to make sure everything propagates before you go and post this story to the homepage. For whatever reason. This is probably the most awesome feature I like that Redis that you could accomplish manually through Redis, but this has it built in. Is time to run, and so you can say, hey, this job should take 10 seconds. And if it doesn't take 10 seconds, if the worker doesn't report back saying, hey, I finished it, or whatever, go ahead and put it back into the queue to be ran. And so this becomes super, super handy. And in case if you do have a weird instance where a worker dies or hangs or whatever, that your job has a little bit more durability that it can be reinserted into the queue and ran automatically again. And then you have data that goes along. I typically just put like a JSON formatted string. Whatever data I want for the job, encode it in JSON and stick it in there. And then my worker will know it'll just decode the JSON. And so Beanstalk has a bunch of different actions. These two are used by what are called the producers, or like your web application that produces a job. You can put a job, or you can put which creates a job, or you can put with a delay. And then your worker, it will reserve a job, which that's kind of saying, I reserve this job, I'm going to work on this job. And then it has the option to, think of an example. You could have a job that, let's say it's has something to do with the blog post that hasn't replicated all the servers. A job can come in and say, hey, I want to do some image manipulation, and it checks, the slaves haven't replicated far enough yet. This doesn't exist. I'm going to go put this back into the queue. You can put it back in the queue with even delay. Say, hey, put this back in the queue and wait 5 seconds before you try again. Or you can delete the job saying, hey, I successfully completed this job. Go ahead and get rid of it. You can bury a job, which is another feature that Redis doesn't. You could build into Redis, but it doesn't have by default. Burying the job says, hey, there was a problem with this job. There's an error or whatever. So go put it in the queue, back in the queue, but in a buried state. So don't give it to another worker. And then you could have some type of other process or some admin tool that goes in and reviews your buried jobs and say what went wrong. And then if you fix the problem, you can kick it back into the queue, or you can go ahead and delete it. And then touch is if you reserve a job and you're doing some work and saying, hey, this is taking longer than expected, you can touch the job saying, hey, don't worry, I haven't died, I'm not gone anywhere, I'm still working on it, and it'll reset the time to run. So if you have time to run for 10 seconds, you get to 9 seconds, you go, oh, I'm still working, you touch the job, they'll say, okay, we'll give you 10 more seconds. And so the typical job life cycle is really simple. The client will put a job, a worker will retrieve that job, and when it's done, it'll delete the job, and poof, the job has been done, we're all good. The possible workflow is you could put the job with the delay, and then when time in delayed state, and when the time passes and becomes ready, a worker could then reserve it. And its options is I could delete it saying it was okay, or say or for whatever reason, you could put it back into the queue, or you could put it back in the queue with a delay, or you could go ahead and bury it, and then if it's buried, you could delete the job, or you could kick it back to a ready state, or you can go ahead and just put the job in without a delay. Like, here's a nice little graph. They had an ASCII graph in the documentation, and it was hard to read on the screen, so I figured I'd try my best at making it look pretty, which I kind of failed, but that's okay. Any questions so far? All right. Okay. So we're going to go ahead and look at some code. Now, unfortunately, I wanted to have a nice, like an admin UI for this demo, and I didn't finish it. So we'll see a little bit less awesome version of it just in the CLI. And so what I've gone ahead and done is I created my application and that can put jobs into a queue, and then a worker that will go ahead and listen to it. So just make sure I still can communicate. Yep. Okay. All right. So let me get the code over here, and I'll increase the size because I'm sure that's probably not the easiest. Oh. I should have paid attention in the last presentation when we had to increase the size. To Sublime, it might be easier just to. I tried Control Plus and it didn't let me. Or I switched my Command and Control. But I did both, and neither worked. I might just Sublime it.
PHP Storm actually makes you enable it in the editor settings first.
Okay.
Which is a little odd.
Okay. So we'll go like this. Okay. CLI worker. There we go. Good?
Good.
Okay. All right, so we'll take a look at this add worker. Typically, this would be like a web site, function. But I have a little command line tool that all it will do is it'll auto-load itself, connect to Beanstalk, and then it will take all the arguments that I pass it. It'll unset the first one because that's the name of the script, and then it'll loop through them and say, hey, here's my job data. I want to do a lookup. I'm passing a type saying, hey, and this type is for the worker. That Beanstalk doesn't care. This is just kind of so the worker knows. Say, hey, I want you to look up a word. Here's the word. Use this queue, put it into a tube called queue, and put that data. And then I echo out saying, hey, I added this word, and then say done. And so what they'll do is they'll take that job, convert it to JSON, put it in the tube queue, and then exit. Say, okay, I'm done. And so then on the worker side, I have a class, and I'll show it down at the end. All that happens is at the end of the file, let me add a couple lines, is I'll say, hey, create a new demo worker, set up all of its configuration, and then go ahead and run. And so here's my worker. In the constructor, I have it do just setting some variables. I can pass it a worker ID so I can have multiple workers, like worker 1, 2, 3, 10, whatever. I like to set what I call a worker hash, which is just when a worker is instantiated, have it assign a random MD5. And that way I can look and see if worker 1 changes hashes, I'm like, okay, that means worker 1, it exited and restarted itself. Here's where I set the start time, my time limit, and I say, okay, the end time is just start time plus how many seconds I'm allowed to run, and then I have some logging function that just outputs to the CLI, the command line. Nothing fancy in the log. I just put a little time at the beginning and the text, and so here's the setup. And say, okay, I'm gonna go ahead and set my time limit to 0, so that way I can run. That way I will control how long it runs, not PHP. It won't error out and saying I've ran too long. I'm gonna go ahead and make a connection to my Redis server so I can talk to that. In fact, let me extend this. And then I'm going to make a connection to my Beanstalk server. And then I like to do what I call a worker version. And so let's say all my workers are in version 1, and I have like 200 of them running across 10 different servers. And let's say I release an update and say, hey, I need to tell all my workers to restart. I can just go ahead and increment my worker version. And later in my code, I'll check to see if that ever changes. And if it does, I say, hey, stop running. Go ahead and restart yourself. And that's an easy way to tell all my workers that, hey, you need to restart yourself because there's new code for you to run. Because these guys, once they load the PHP once and they run for however many hours, if that PHP changes, they have no idea. All right. Okay. So then my run function is really, really simple. I say, hey, I'm going to begin to run. And then it says while run is equal to true, which in my constructor, I set that to be the default. I say, hey, Beanstalk, watch the system queue, which I could do for like high priority system alerts. Like I say, hey, all my workers, I need to do this, whatever. I could also watch my normal queue, and then I ignore the default queue. With Beanstalk, by default, if you don't assign it a tube by default, it'll go in the default tube, and all Beanstalk instances by default will listen to the default tube. And so I like to be more explicit in saying which ones they're watching and not. So I just like say, hey, I'm not going to use the default queue. If something gets in the default queue, it was by mistake, and I don't want that mucking up all my workers out there. And so then I pass it this reserve, and then I give it a timeout saying, hey, connect. If there's a job, it'll grab it immediately. If not, wait for up to 10 seconds. And if in those 10 seconds the job comes in, it'll grab it and then process it. And then if not, it'll just return false. And so this is kind of nice. I could put I'll do it right here. I could put like an echo, a little dot, kind of like a tick. So that way I can see and watch, hey, it's not hung up or anything, it's processing just fine. And then if I do get a job, I tell it to process the job. And so, process job, I could use some reflection and do some more sophisticated things of having it auto-generate this functioning, but I thought it'd be more explicit for the sake of the demo. I say, hey, get the job and send it to my this job, get its details and decode it, and save it into a method so I can use it later in here. And then I can just switch this detail type. And if there's a case for like a restart, I can say, hey, go ahead and restart yourself. If there's a lookup, I can say, hey, go perform the lookup operation. And then otherwise, I don't know what the type of job this is. I can throw like an error. And then so my job error, I could echo it, say, hey, unknown job, job ID, blah. Here's the data for that job. And then I could go ahead and bury it. Because if I didn't delete it and if I didn't bury it, what would happen is after the time to run passed, it would reinsert it into the queue. And then I actually had that happen when I was debugging stuff. I was like, where are all these jobs coming from? I'm like, oh yeah, they're reinserting themselves into the queue. And so this buries the job, and then some other process, an admin or someone can go take a look at the job and say, what's wrong with this? And if I was really smart, I could, write to Redis or something those details of like some more useful information of why the job got buried, and then my admin tool can just pull that information up. And so this buried job will stay in the queue. I keep mixing the words. It'll stay in the tube, but it won't get passed to a worker until it gets kicked, or you can delete it. Restart, really simple. I say, hey, job restart received. I'm going to stop running. I'm going to hit false, and I'm going to delete the job. Once again, one mistake I could make is I could just like exit right here and say, hey, I received a restart, I'm exiting. But if I don't report back that I completed this job successfully by deleting it, it's going to be reinserted into the queue, and then that restart command, that restart job is going to propagate and propagate and propagate, and I'll have lots of fun. And so here is the job lookup word, which is what our demo is going to use. The most important thing is I wanted to do a demo where I pass a word and look up a definition. Apparently there's no good APIs for that. Webster's has an API that uses XML, which I had to remember how to use the simple XML element, which is why you might look and see why it's kind of, and the XML they pass back is wicked, like weird. So that's why if you see like why I'm kind of using weird XPath and then rendering it as XML and then manually like removing stuff, is I couldn't figure out how to play nice with it, so I just hacked it together. So if this is an XML class, don't do this. And so
more lines of code to play nice with it.
yeah, and then the way it returned definitions, it like have like a 2-word definition, which for the first one, and then the second one would have a more verbose one. I'm like, oh, I want the more verbose one. So I say, hey, because it'll return like 20 different definitions. So give me the longest definition, and that will provide for some interesting results, but it'll be fun. And then it'll go ahead and echo this word. Typically what I would do is, if my application was finished, I would write this information to something like Redis or something like that, and then have a nice admin page with like Twitter Bootstrap and use Socket.io to automatically update. I just didn't have time. So hopefully before I go to my next conference, I'll get that done. But you guys can see the simple version with just the command line. And then I go and say, hey, delete this job. And then I'm going to wait 2 seconds because I don't want Webster to throttle me. I don't know. They said they have a limit. They didn't say what the limit was at all. But they said there is definitely a limit. So I'm just guessing that. I'm just like, hey, just only ask every 2 seconds. All right. And then at the end of my job, if you go up here, run process job. If there's an exception, go ahead and get that. Oh, whoops. Okay. And then what I should do is this. What did I call it? Check status? Check status. And what that will do is say, hey, have I been running too long? Okay, stop running. Or hey, the work version changed, stop running. And then it'll set run to false, which this will return false. Oh, this while's in the wrong spot. Sorry, guys. This is what happens when I code at 2 a.m. And then at the end, I say do some cleanup, which I might like register in Redis saying, hey, I've cleaned up, this worker's been terminated, whatever. Do some cleanup functionality. A lot of times I started writing workers, I would just exit, but I found it was a lot cleaner experience, a lot easier to manage the code if I just set the run to false and return. So check status, just make sure I'm still good to run. Now that I've changed code, watch my demo won't work, but all right. Okay, so this project's using Vagrant. So if you were to go in, is there a question? Or?
Can you make that bigger?
Oh, yeah, I guess. Is that big enough? It's not the best. Let me bring this over here so I can resize it. And I'll do that for this one. Bring that back over here. Okay. So what I'm going to do is I'm going to just run my worker. I could pass an ID of 1. Of course. That's what I get for making a change to my code. And I don't think that goes there. Okay. So you can say, hey, I constructed my worker. It has ID of 1. I created a hash, set timeout, beginning to run. So sitting there waiting. I have a bug in my check status, so I'm going to just comment that out. Nobody watch what I'm doing. Don't look at them. Don't look at the man behind the. Okay, so every 10 seconds I should see a little tick dot. I probably should have made it 2 seconds so I could see it sooner. Okay. Yay! All right. Okay, so that's sitting there listening, and I could have one, I could have multiples of these, and if I have time, I'll do a couple of them, But I'm going to go ahead and add word fun. Oh, I might make that. Here's what I'll do. I'll go like this. I'm real professional here. All right, okay. Add word fun. And so you can see, I had the dot, and then it received the job. And if I had some logging to say I received the job, you would be able to see it. But then my thing that says, okay, fun, amusement, enjoyment, sickness takes all the fun out of life. Okay, that's the longest definition that Webster had for fun. Let's try boring. Tiresome, a boring lecture. All right. My work here is done. Let's see if I can spell it right. Procrastination. To put off intentionally doing something that should be done. That's what I did with these slides, or that's what I did with my demo at least. But then what I can do is we're going to be really brave here. And I'm going to find, let's go to Wikipedia. Okay. Ooh, this might break it. What I'm going to do is PHP add word. I'm going to paste a bunch of words. And I threw an exception. Yeah, probably the commas. Yeah, it's probably complaining, saying I couldn't, that was an invalid. So what we'll do is now, what I normally do is supervisor or solo would restart my worker for me because I'm just running it manually myself.
No, you don't do it.
My queue. Now if I had my tools, like clear queue, I could do that. But I'll just do this. Oh, awesome.
You have a max number of bell jobs.
Oh. Okay, so the next thing we're going to do is even more professional for my demo. Is I'm going to go here, Q2. Don't do this in production. Oh, you guys are good sports. Thank you. Okay.
We've all done it.
Okay. So PHP add word. This demo is going absolutely great. Except I can't see if I typed great right. I didn't. Okay. So it should queue up all those words. Should being a strong word. Okay. Enter. So this demo is, didn't have a definition, going, absolutely. And then if I'm really brave, I'll dnews, that's muscle memory. PHP word tutorial, vagrant. Oh. CLI. Okay. So now, if I do that same thing, one went to this one, and the other one went to this one.
Yeah, that's great.
Yeah. And I tell you, if I had the servers, yeah, my demo worked. Okay. Thank you guys, you're way too kind. All right, so if we go back to the presentation. So I mentioned high performance in my title. I figured I might want to talk about that. And so using workers to increase your performance is first step is to make a writing to your queue extremely fast. So Beanstalk, Redis, some type of in-memory. These both can operate in memory, so it's very, very fast. And then in your actual web application request, only do what you must. And then if you can, queue the rest of the stuff. And then find your I/O operations, whether writing to a database or whatever, and queue them instead of performing them. And so think of what caching is to reads, queuing is for writes, or other jobs, things like that. And so you could queue a bunch of things. You could do logging, analytics. You could do some database queries. You could queue communication with APIs, writing to data sources, and then you can identify what to queue. There's a tool called XHGUI and XHProf that allows you to profile stuff in production. It's pretty cool, in a manner that won't kill your production. Facebook uses it. They're the ones who originally wrote it, and then some guys came out and wrote XHGUI, which is just a nice interface for it. You can use stats in Graphite to gather stats across your different web requests to see, hey, this one thing we do like 50 million times a second. Well, maybe not that high, but you do a ton. You can do like 100 times per second. That'd be a great thing maybe to queue. And if it communicates to something else, there's a high potential for queuing it instead of actually processing it. All right. Any questions? I almost feel like I did a poor job if there's no questions. All right.
So that's auto scheme you used for calling up the dictionary would only work if you only have one worker, right? Like you did in this instance, because you just had it sleep for 2 seconds during this specific worker. So how would you do that?
Excellent question. Excellent question. So what I probably would do, man, that's a really good question. I don't think I would do that. Because you're right. Because if I could only run 2 operations per second, or even it was like you can only run like 5 per second, you want to keep track of that. What I would do is Redis. I would probably have a worker get a job. I don't know if this would be a perfect way of doing it, but what I would first try is I'd get Redis. So it would get a job, and then ideally what you'd have is you'd have a queue, and then you'd get a queue.
Time delay also.
You'd almost have, time delay on a specific queue. So what you could do is you'd put in so you'd have a queue that says words to be queued, and then you have a worker that goes in and checks the last time something been entered and say, hey, this now has a delay of 10 seconds because there were 4 other entries before it. And then it gets put into that queue, and you can have the same workers, managing both those things. And then when a job comes through on the word lookup, then it can go out and execute. That's how I would try to approach it first. And then there might be a more elegant way to do it, but because I'm presenting live, I can't think of it. So that's what I would try first. That's an excellent question. Thank you. Any other questions?
So you could do a lookup with the last query and then with the next query, and so basically just straight on time. So when it looks it up, and then you get critical time and sleep that amount, so then you wouldn't have to do it as the words come in. Just as
That's
the
true.
waits to grab it, it can do it on the fly.
Yep. Yeah. There's some fun stuff, and that's why I like queues, because you can solve some of these problems in at least a much better, more elegant way than having one cron that runs every minute that looks up the jobs and waits, and then hopefully the cron won't run again on itself. I used to have a cron that ran every day, and the problem is it came to a point where it would take longer than a day for it to run. So to come into the office and things were grinding to a halt, and I had 4 days worth of these crons all halfway through a day. Anyways, that was a fun. Any other questions?
So if you have something that you want to just run at night, does that delay allow you to use time limit, or do you have to base it off of when it's put in? Or?
So what I would do, so a couple options is if you only want stuff to run at night, you could queue up, put it into a queue, and I would use a more durable. I'd have a Beanstalk instance that I was writing to disk for durable, but I could actually see you putting into a queue. These emails need to be sent out in the morning, and then at whatever 3 o'clock in the morning, you start your workers at that time. Say, hey, start up at 3 o'clock in the morning, and then go ahead and turn yourselves off at 8 or whatever. That way, they'll go and process it all, go through the queue, and then once they're done, a lot of times pass. Okay, turn themselves off. You guys have great questions. All right, any other questions?
Out of curiosity, but how often do you run into memory limits?
Into memory limits? Not very often. Memory's pretty cheap these days. So so where you could run into tricks is if you were putting, for example, like if you were like base 64 encoding like your image data and putting that in the job, then you can run into memory limits, and you can configure in Beanstalk the max value of a job can have. But you could up that up. But I can see you running into problems there. In that case, I would almost rather have it just say, hey, here's an image location, and then when the job gets it, it can go out and grab that image and perform its logic. But typically, I haven't run into too many image size issues. On the queuing side, I ran into limitations on the Redis side if I was storing tons of data in there. But typically, the queues, I personally haven't run into any problems. Okay, I can't see what time it is. All right, I'll give you guys any other quick questions. Well, you can talk afterwards, and I'll let you get to the next class or lunch. So, all right. Thank you.